Namaskar my dear friends. Let's talk about LTSpice simulation. In this schematic demonstration we'll try to see how we can supply system supply using two MOSFETs. So basically this configuration is also called as high side switching. So what happens is basically we have a battery supply, or let us say we have some regulator voltage supply. So that supply has to be transferred to the system load, and there will be a switching circuit. It is kind of a switching on switching off circuit which will be making sure whenever the system is not working, the system is not draining the power from my supply source, that is from my battery. So it will be totally cut off. Okay, and whenever there is a need to give a supply to the system, there will be a switching action here, and this is how the battery supply will be connected to the system. So this is how it is called as high side switching. Okay, so you can consider very simply what will happen is, let us say this is high power MOSFET which is having a very good capacity of carrying the current. This is my source terminal, this is my drain terminal, and this is my gate. Okay, and this is my PMOS, like P MOSFET, P channel MOSFET. So this particular battery, or let's say some particular voltage source which is connected here, that is going to get switched on and it will give to the load. So this is my V output going to the load or to the system. Okay, so how we can drive this one very easily? Let us say we have tied this up the gate to high voltage, right? So this V input has been pulled up. It means what will happen, this particular MOSFET will be always off. So whenever there is a need to switch on this particular voltage to this V output, what will happen is we will try to have a enable or disable signal from here. Okay, like this. So what will happen is whenever we want to make it switch on, we will give a high signal here at this gate, and this gate, what it will do, this gate will drive this particular MOSFET M2, which is N channel MOSFET, and this drain to source get sorted. It means this drain will be pulled get sorted to source, and this gate will be pulled down. So as you can see, the voltage difference between source and gate is much higher. In that case, this particular MOSFET will switch on, and this is how the supply will get transferred to the V out. Okay, so hope you have a very good understanding about how to switch on this particular input to output. One more thing you can see many of the circuit designers are doing is, instead of using MOSFET, they are using transistors. So NPN transistor also can be used to do this particular job at this low power switching here. So here very low current carrying capacity MOSFET or transistor can be utilized, and here we will have to use bit higher carrying capacity of current carrying capacity of MOSFET. Okay, so that is the more or less we have to understand how much load it is consuming, or what is the current rating that is needed to drive the load. In that way we will be utilizing mainly little bit high power of MOSFETs. So what we'll do is we'll try to do this simulation, and we'll try to see what is my input and what is my output. Okay, so as you can see very easily here, we have input voltage, that is green color, 12 volt, and whenever this is my enable voltage, which is this one. Okay, so whenever this enable voltage goes high, my gate will be switched on, and this is how this is going to switch on this particular MOSFET M1. And what will happen, whenever this goes high, my output will be high. Okay, whenever you want to switch it off, you pull it down again. Okay, enable signal will go down, so you can see output voltage has goes down, that is 0. So this is what is happening. So whenever you need to switch on this particular voltage from left side to right side, you have to give a high signal at this particular place, and whenever you have to switch it off, you have to just pull it low through the microcontroller controls. Okay, so let's open LTSpice, and we'll just quickly do this particular circuit. So what we can do is we can open a new circuit by clicking new schematic or control N, or go to file and put new schematic. Any method you can do that. Okay, so I'll just place this. We are done. Now we'll place two MOSFET here. So by pressing P, we can go to component part, and we'll place P MOSFET one. Okay, so we will place one PMOS. I'll just put control R to rotate it. Okay, and let's say I'll just rotate like this, and then press control E to mirror it. Okay, I'll escape this. Now we'll press NMOS, we need one, right? So this is my NMOS. So NMOS will be driving the low side, right? Okay, so this is done. Now we need two voltage sources. One will be acting as a source supply or something like that. Another one we will make sure that it is acting as a enable disable signal. And we need few resistors. So one resistor I'll need to tie it high, and one more resistor I may need here to pull it down. One can be acting as a load, one more acting as a voltage divider, and one more I can act it here. Okay, so this can be a pretty good circuit. Now we can place some grounds. Okay, so this will be one ground here, one ground here, one ground I'll put it here. I can put one ground here as well, and this one. So this particular circuit is now done. Now what we can do is we can wire this up. To wire this up circuit, we can press this icon. This is called W, or W you press, then you will get the wire signal. Okay, so you can quickly wire this circuit. Okay, so wiring the circuit, like can be done one by one by clicking and leaving the node. Okay, so this is very easy. Or what you can do is you can keep on clicking like this. If you can click, sorry, press W and you keep on clicking. So this particular circuit is almost complete. Okay. Now what we can do is we can supply some of the values. So first of all, what we can do is we can give a value here. Let us say we'll put it 20 kilo ohm, and so that we do not drain the circuit when it is off. That time also we have to take care of, or you can increase if you want more. We can keep it 1.2k or 1k, something like that. This value we can keep it, let's say 4.7 kilo ohm. This gate resistor I can keep it 100 ohm. Let us say this load resistor, let's say we'll keep 10 kilo ohm. Okay, if you want you can reduce it also, no problem. What we'll do is this particular voltage source will keep it as a battery voltage. Let us say 12 volt simple DC source will keep, and this one we have to keep a pulse signal. What we want to do, whenever we want to switch it on, it will go high, and whenever we want to switch it off, it will go low. So in that case we want to have a advanced source. In that we'll go to pulse and we'll put it, let us say we want to make it 0. Then V on will be, let us say 3.3 volt or 5 volt, whatever you want you can keep it, no problem. If you want you can keep it 5 volt also, but generally all the microcontrollers are 3.3 volt source, so it will be 3.3. Time delay will keep 0. Let us say time rise I'll just keep 1 microsecond, time fall I'll keep 1 microsecond, on time I'll just keep, let's say 10 millisecond. Okay. And if you want to give a period we can give it, otherwise we can always keep it on, not a problem. So my circuit is now almost ready. I'll just pull it down so that it becomes little okay. Now the other part that we can do is we are now ready to go ahead and we can configure the analysis. To configure the analysis, what we can do is just press this and let's say stop time. What we want is we will just have, let's say 3 pulses. So in that case 3 pulses, we have 20 millisecond pulse time. So 20 into 3, that is, let's say 60 millisecond will run it, and then we'll start saving data from 0 and press OK. So this is my transient analysis setting, that is done. Now we run the circuit. So once we run the circuit, I'll just keep it right side. So once we run the circuit, what is happening is you can see my input voltage is there. So before doing that, what we'll do is we'll name the node so that we can view it very clearly, that which node, what is the voltage level on which node. So for that, what we can do to name any nets, we can press N to get a net name, right? So this will be my V input. So this is my V input. This can be my V output, this can be my V enable. Okay, so I'll just rename them by right clicking. This is my enable, and here also right click it, and this will be my V out. Okay, so this is how you can change the net names directly by keeping the cursor on that and right click it, and you can get a idea of changing the nets. Let's rerun that net. So what you can do is, let us delete this. Now what we will do is we'll just rerun it again, and we are seeing that my V input is 12 volt As you can see, we have V output. So before that V output, what we'll do is we'll go enable signal. So this is my enable signal. To view this very clearly, what we can do is we can take this one in new window. So I'll just put it, let us say, above, and I'll put this one in this one. So whenever this is going high, I have to have my output voltage to be high, and whenever this is going low, I have to have my output voltage to be low. That's the main point we want to see. Okay, so I'll keep my cursor in this window and I'll just press voltage probe in this particular, like a voltage probe. So you will see, whenever this is going high, it is going high, but it is not going to 12 volt. It should be going to 12 volt, right? Because 12 volt is the input, so my output should be 12 volt whenever this is on, right? So this is not happening. What could be the reason? My V of V out is not going very high, like it is not going to the input level. So for that, the main reason can be this MOSFET is not practical MOSFET, or it is not the actual MOSFET that we have chosen. So for that purpose, what we can do is we can pick a actual part for this MOSFET and this MOSFET. Okay, so just right click on this part and we can see a option pick new MOSFET. So click on that and you can see whichever MOSFET you want, you can keep it, click it. Okay, so any P-MOSFET we can take up right now, because we don't have to be very particular about very high current rating MOSFET. That we can do it later. Okay, so any of the MOSFET, let us say we will just take up some SI series. Okay, so SI series MOSFET, let us say we'll take this one. Okay, so this is done, and we will need to have a N channel MOSFET also. So N channel MOSFET also will pick up. So N channel MOSFET, let us say we'll just take some B series something 40 volt ratings. Okay, so this is also done. Now we are ready to rerun again, and as you can see, my V output is reaching to the output level. Okay, so whenever my enable signal is on, my output is on, equal to the input level, right? And whenever my enable signal is low, my output signal is low. So main reason is, whenever microcontroller wants to switch it on the battery voltage to the load, it will keep it high. That's all, and keep it high always, so that it is always keep on giving the power, right? And whenever you want to make it off, like you do not want to supply power to the load, at that time you can pull it low, right? So this is how I am pulling it low. One more thing that you can do a practice by yourself is, you can change this particular MOSFET to transistor and do the same job. Okay, so let's try to do that as well. What we can do is we can copy this particular circuit. Okay, just copy this particular circuit completely. Let's take a new window by pressing Ctrl N and put the circuit here. And what I'll do is I'll just change this particular MOSFET to transistor. So I will put it here, NPN transistor. So press P to get a part window, and I'll put NPN transistor. Okay, so this NPN transistor will help me to switch it on, switch it off, something like that. So I can do one thing, just delete them up and rewire again. Okay, so place this again. Now what I want to do is I want to wire it up. So I can press the W to get wiring, and the thing is, if you want, you can increase the gate base resistance. So base resistance, let us say I will keep 10 kilo ohm. This also I can keep 10 kilo ohm, because I need minimum 0.65 volt or 0.7 volt at the base of the NPN transistor, otherwise it will not switch on. So I am making sure that it is going to be around 1.65 volt, like more than 1.5 volt. So now it will switch on, switch off, everything will happen, but there will be a loss of 0.2 volt or 3 volt saturation voltage across the NPN transistor. So right click it and pick a new transistor here, and you can select any of the transistors. So we will take up this one, first one itself, not a problem. Now we can rerun the circuit. Okay, so this is my transistor based circuit, this one is transistor based circuit, this is my MOSFET based circuit, right? So what we can do is we can see my input voltage is coming here 12 volt, my enable signal is there, which is my pulse signal going up to 3.3 volt and 0, and my output signal will be following the input signal whenever this is high, right? So my output signal will go here, and as you can see, it is whenever it is going high, the enable voltage, my red signal, which is V of V out, is going high, and whenever my enable signal is low, it is going low, right? So this is how you can incorporate two kinds of switching circuit for your system supply. That is also called high side system switching, using either MOSFET or transistors. So hope you have now a very good idea about how to design this particular circuit and understand how we can drive our load to the by the system supply or by the sources which of battery or maybe regulated power supply. But you have to make sure the MOSFET that you are choosing, that is P-MOSFET, must be having a current carrying capacity of high enough so that it doesn't fail. Like source to drain current must be a good enough. Let's say you have a rating of requirement of 1 ampere, then you choose a MOSFET of rating minimum 3 ampere or 4 ampere, then it will be a very good design. Thank you so much.